You give an advanced AI coding assistant this seemingly straightforward prompt.
Right, just a simple task.
Yeah, exactly. And then like 2 minutes later, it has hallucinated a non-existent library,
Yeah.
deleted a critical configuration file, and entirely misunderstood the core architecture of your project.
It's honestly wild when you see it happen in real time.
It is. And it brings up this massive question, which is, why do models that have ingested literally more source code than a human could read in 1,000 lifetimes make such mind-bogglingly dumb mistakes?
That's the real paradox right there.
Right. And that is exactly the problem we are unpacking for you on today's deep dive. We're going to look really closely at the hidden mechanics of coding agents.
So tools like Claude Code and GitHub Copilot.
Exactly. Our mission today is to figure out the technical reasons why they fail in real-world environments, and more importantly, how you can architect a workflow that makes them actually, significantly more effective.
Yeah, moving beyond just the theoretical hype.
Right. We are synthesizing some fascinating recent developer notes, internal evaluations from Microsoft and GitHub, and some really practical deployment strategies, just to give you a definitive look at making these agents actually work.
Because, the gap between having vast training data and actual practical execution, that is the defining challenge of this current generation of coding tools.
Absolutely.
We have to look at the hard data of how these systems behave, or, misbehave, when they get dropped into a really messy production-grade repository.
Okay, let's unpack this, starting with what I think is a massive trap. Developer evaluations highlighted this as the single biggest point of failure.
Oh, the mind-reading trap.
Yes. The absolute fastest way to make a sophisticated coding agent look completely incompetent is to assign it a task where the criteria for success only exist inside your own head.
Yeah, what's fascinating here is how Microsoft's evaluations of agent behavior really drilled down into this specific vulnerability. When developers use these tools, they inherently suffer from this curse of knowledge. Like, your repository inside and out, right?
Sure, you live in it every day.
Exactly. You know why that one legacy routing file has a weird naming convention. You understand all the unwritten architectural rules your specific team follows.
But the agent doesn't.
Right. Every single time an agent opens your repository, it's entering a completely unfamiliar environment. It has zero memory of your team's culture.
I always think about this like hiring the world's absolute fastest typist to transcribe an incredibly important document.
Okay, I like that.
Mechanically, they can type, 200 words a minute without breaking a sweat. But imagine they don't actually speak the language they're transcribing.
Oh, wow. Yeah.
They have the raw mechanical capability to generate the output, but they lack the localized judgment to catch semantic errors or slang or any context-specific nuance.
Because they're just pressing keys based on sounds.
Right. They're just pressing the keys. So if we just dump the entire repository into the agent's context window, we sort of assume it automatically understands the nuance of the project. But context is not the same as judgment.
It really isn't. And that distinction between context and judgment is so fundamental to understanding why these agents fail.
Break that down a bit more.
Sure. So let's look at how a large language model actually processes that massive repository dump. The context window is ultimately just a huge string of tokens.
Just numbers, essentially.
Exactly. And the model is exceptionally good at mapping the statistical relationships between those tokens. So it can easily identify, like, oh, you're using a specific React component pattern here.
Or a certain database ORM, right?
Yeah, exactly. But what it cannot do is assign business value or strict acceptance criteria to those tokens, not without an external heuristic.
So if I ask the agent to add a user login module, it might infer from the existing tokens that we use PostgreSQL. But it can't mathematically infer whether we need, say, OAuth, or just a basic email password schema, or some highly specific compliance-driven multi-factor authentication flow.
No, we can't. Because those are judgment calls.
Right.
And when GitHub evaluated Copilot's agentic harness across different models, the data was pretty stark. It clearly showed what happens when agents are forced to make those judgment calls without a clearly defined finish line.
What do?
They drift. Left to their own devices, the models will just competently write code that is syntactically perfect in a vacuum, but entirely useless for your specific application.
Because it doesn't know what done looks like.
Exactly. For a coding agent to succeed, The success metrics must be external, executable, and visible before the agent starts editing a single line of code.
Wait, external, executable, and visible. That's a great way to put it.
Yeah, it has to be measurable.
So the agent basically cannot be allowed to define its own success criteria on the fly. We have to provide a concrete measurement framework, and this leads directly into the whole concept of receipts, right?
Yes. Receipts are huge right now.
Which is a practice that internal analytics teams have been relying on for a while, and now it's finally migrating over into software development.
Yeah, because internal data parsing agents face a very similar problem. If you have an AI tool tasked with analyzing, say, millions of rows of financial data,
Right.
and it simply spits out, revenue is up 12%. I mean, that is functionally useless.
You can't trust it. You can't base a huge business decision on an unverified output.
Exactly. The analytics teams learned pretty quickly that the agent must provide the answer alongside the exact SQL query it ran.
Oh, like showing its work in math class.
Basically, it has to show the tables it joined,
Yeah.
the filters it applied. It has to prove how it got there.
You demand a receipt.
You demand a receipt.
And applying this to coding agents, like Claude Code, means the AI needs a way to actually execute the code it writes to prove that it works, not just generating text and hoping for the best.
Right, which requires a pretty big shift in how we handle the execution environment.
Right, and the sources pointed to leaning on technologies like OPFS and Pyodide to build these portable local test harnesses.
Yeah, those are game changers.
By leveraging OPFS, which is the Origin private file system, for those who might not be familiar, and Pyodide, we can actually give the agent a high-performance, sandboxed, browser-native execution environment.
And the mechanics of how OPFS and Pyodide interact are really what make this so reliable. Because traditionally, if you wanted an AI to safely execute and test Python code, for example,
You have to spin up a cloud container, right?
exactly, you had to route that request to a cloud-based container. And that introduces latency, security risks with your proprietary code.
Nobody wants their code leaving their machine if they can avoid it.
Right, plus there's massive infrastructure overhead.
That's
But
right.
OPFS changes that whole architecture. It provides a virtual file system that operates directly on the user's local disk, but it is securely isolated within the browser.
So it's safe, but fast.
Super fast. It allows for highly efficient synchronous read and write operations.
And then when you combine that with Pyodide, which compiles the Python runtime to WebAssembly so it runs natively in the browser, you suddenly have this incredible localized testing loop.
Yes, entirely local.
The agent can generate a piece of code, write it directly to the OPFS, and then use Pyodide to run a test harness against those files.
Catching its own errors.
Exactly. It captures the standard output, reads the error logs, and literally iterates on its own code without ever leaving that secure local environment.
Right.
Or risking, a catastrophic overwrite of your actual development machine.
It tests its own work and hands you a verifiable receipt.
Okay, but let me play devil's advocate on this workflow for a second.
Go for it.
Because here's where it gets really interesting, but also maybe a bit tedious. The primary appeal of AI coding tools is velocity. We want to move fast.
Sure.
If developers now have to spend all their time architecting these OPFS environments, defining explicit local check parameters, and enforcing test harnesses for every minor function the AI writes, doesn't that destroy the speed advantage?
It seems like it would, yeah.
I mean, spending 20 minutes defining a test environment so an AI can write a 5-minute function, that feels like a net negative return on investment.
I hear that all the time. But if we connect this to the bigger picture, it only looks like a net negative if you only measure the time it takes to generate the initial keystroke.
Right.
But the velocity metric that actually matters in software engineering isn't typing speed. It's the time it takes to get working, maintainable code into production.
That's a good point.
What happens when an agent moves at maximum speed without a localized check and without generating a receipt?
Well, it injects code that looks totally correct, but contains, a really subtle logical flaw.
Yes.
And you don't discover it until the build pipeline fails, or worse, until it actually hits production.
Precisely. And then what happens? The human developer has to step in, reverse engineer the agent's hallucinated logic,
Which is awful.
untangle the spaghetti code,
Yeah.
and manually debug a silent failure. I mean, that process can take hours,
Yeah.
sometimes days. So that slight upfront friction of defining a local test harness, it acts as an absolute guardrail against those silent, catastrophic failures.
You're spending minutes to save hours.
Exactly. The time saved by eliminating the manual debugging of AI hallucinations makes these local checks mandatory for a serious production workflow. You're basically trading unpredictable bursts of speed for sustained, reliable velocity.
You shift the agent from being a slot machine where you pull the lever and hope for good code
Right.
into an actual reliable compilation step. But this requires a fundamental change in how we interact with the repository itself.
It really does.
If we know that agents fail in unfamiliar code bases and we know they absolutely require executable receipts to succeed, we have to enforce those boundaries operationally. Which brings us to what the source is called the verification contract.
Ah, yes. Verification contract. This is really the architectural blueprint for making your repository agent-friendly.
Because you can't just expect the agent to intuit your testing culture.
No, never. You have to build shared practices directly into the repository structure so the agent encounters them immediately when it boots up.
And a highly effective implementation of this, which I loved reading about, is creating a verify y.md file right in the root of your project, just sitting there alongside your README.
Yes. Or updating your issue templates to include explicit, mandatory verification fields.
You are essentially hard-coding the rules of engagement for the AI before the session even begins.
Exactly.
And the workflow strategies we reviewed break this contract down into 3 very specific enforceable steps. I want to go through these.
Let's do it. Step 1 is crucial for establishing that external success metric we talked about.
Right.
Before the agent is permitted to write or edit a single line of application code, you explicitly instruct it to identify the smallest possible test, the exact terminal command, or the specific manual check that will prove the issue is actually resolved.
You force it to read the issue and declare exactly how it will measure success. But step 2 is where the actual control mechanism kicks in. If the agent determines that no such test or check currently exists in the code base.
Which happens a lot in legacy code.
Oh, all the time. If it doesn't exist, you instruct the agent to propose a new test, and then, and this is the critical part, stop and wait for human approval.
We really have to look at why that forced pause is so technically important.
Yeah.
It comes down to breaking the large language model's autoregressive generation loop.
So what does this all mean mechanically?
Yeah.
Because an LLM is fundamentally just predicting the next most statistically likely token based on its context window, right?
Right. So if you let the agent run continuously without that pause, and it decides to write a test for a new feature, it is generating that test in the exact same continuous stream of probability that it uses to write the feature itself.
Huh. So they infect each other.
Exactly. If it has a flawed understanding of your architecture, it will confidently generate a flawed test that perfectly matches its flawed feature code.
Wow. It grades its own homework and gives itself a perfect score.
Yes. By forcing a hard stop, you sever that generation loop. You, the human, step in as the executive function. You evaluate the proposed test against actual business logic, and you inject human ground truth back into the prompt history before the agent generates the payload code.
You prevent the hallucination cascade before it even starts.
Exactly.
And then step 3 of the contract requires that the agent's final output, the actual receipt it hands back to you, must include the exact terminal command it ran, the literal standard output it received, a precise manifest of the files it modified, and, I love this part, an honest list of anything that remains unverified.
Yeah, defining the boundaries of what it could not check is just as vital as proving what it did check.
Right.
A robust verification contract basically demands epistemological humility from the agent.
That's a great phrase.
It has to explicitly state its own blind spots.
Let's scale this up a bit, because a workflow like this has massive implications when you move from, say, a solo developer hacking on a weekend to an engineering organization with 50 or 100 people.
Oh, definitely.
If you're managing a team, you cannot have 50 different developers using 50 different idiosyncratic prompting styles with their AI agents.
No, that's a nightmare. You end up with a chaotic code base full of undocumented AI-generated logic.
Total spaghetti code. So scaling AI coding assistance requires treating this verification contract as a core part of your CI/CD pipeline.
Your continuous integration and continuous deployment.
Yes. When a verify.md file is universally enforced across an organization, it standardizes how these agents interact with the CI/CD systems.
And those portable OPFS and Py.H checks we discussed earlier, they can be mapped directly to the automated test suites running on your build servers.
Oh, so it all ties together seamlessly.
Exactly. When every developer enforces the same boundaries, the agent ceases to be this unpredictable rogue variable and becomes a standardized, predictable build tool.
We really just have to radically shift how we view these systems. I mean, the marketing often presents AI coding assistants as these like omniscient senior developers who can just magically intuit elegant solutions from a vague prompt.
Right, they just tell it what to do. Marketing.
Yeah. But the reality of engineering requires us to treat them more like incredibly powerful but highly literal pieces of heavy industrial machinery.
That's a really good analogy.
They have immense capacity to do work, but they absolutely require strict operational boundaries and safety switches to avoid, tearing the factory apart.
By enforcing a verification contract, you engineer a system where the AI is mathematically forced to prove its work against your specific localized criteria.
You eliminate the guesswork.
Completely.
Yeah.
The agent is forced to interact with the measurable reality of your repository's execution environment, rather than drifting off into its own internal probability distributions.
Going back to our earlier analogy, you basically turn on the lights in the room, hand the typist the exact dictionary for the language they are transcribing,
Right.
and you refuse to accept the document until they run it through the spell checker themselves. So, as we bring this all together for you, the key takeaway is universal. Whether you're outlining an AI policy for a massive engineering team or just hacking on a personal project, your coding agents, no matter how advanced the underlying models become, will only ever be as reliable as the finish lines you draw for them.
Stop expecting the models to read your mind.
Exactly. Start engineering your repositories to demand receipts.
It is a fundamental paradigm shift. I mean, we are moving away from the era of prompt engineering, which, let's be honest, was always a bit of a dark art.
Oh, absolutely. Lots of trial and error.
And we're entering the era of verification engineering, which is actually built on concrete, proven software development principles.
I love that. Verification engineering. But I want to leave you with a final thought to mull over, because the developer notes we analyzed point toward a rapidly approaching shift in how these agents handle the concept of state.
Oh, this is the really futuristic part.
Yeah. Throughout this deep dive, our entire premise has rested on the challenge of the unfamiliar repository, right? The idea that every time an agent opens your project, it basically suffers from total amnesia.
Right, it forgets everything.
It has to reread the verify.md, reestablish the rules, and renegotiate that verification contract from scratch every single time.
But the architecture is shifting towards something called agent memory.
Yes. Introducing persistent memory across sessions fundamentally rewires this entire interaction model.
It really does.
Just imagine what happens to your workflow when an agent can persistently remember the outcomes of its past verification contracts with your specific codebase.
It starts learning.
If today's tools are like a typist who forgets the language rules the moment they turn off their computer, but what happens tomorrow when that tool retains a permanent index of every local check, every API quirk, and every single corrected architectural mistake?
It becomes deeply specialized to your team.
Will future coding agents not just parse our code, but permanently internalize the unique culture and unwritten rules of our testing environments?
That's the billion-dollar question.
If an agent never forgets a receipt, the line between an external tool and a dedicated, experienced team member becomes incredibly blurry.
It's a massive implication for the future of software development.
It really is, and it's definitely something to keep in mind the next time you enforce a verification contract in your own projects. Thanks for exploring the mechanics with us, and we'll see you on the next deep dive.